You guys go through and introduce yourselves and what you guys are doing in the space. Why I picked you for your specific target. Before that goes on, I'll say Antoine is representing air, Dane is representing immersion, and Ryan is representing hydro or hybrid cooling. So,
morning everyone. I'm Antoine from 256 Heat. I do air-cooled systems, and just grateful to be here, and really appreciative of the organizers and the attendees. So, thanks.
Dane Jodan, work on the immersion side, the hashrate house out there that's heating those little tubs, and courtesy of Cody's genius on those things, and just really dove down the rabbit hole of immersion mining, and just trying to started with fixing the noise, and then found all the other benefits that go with it. So, thanks for being here.
Good morning, everybody. I'm Ryan Raminger. I'm the founder and CEO of CryoBite Labs. We specialize in direct-to-chip cooling for proof-of-work mining. Been mining now going on 13 years. Started with a CPU, actually. It was like my bid axe at the time to learn all about it. And I've had the privilege of being able to work with a lot of different cooling methods, but I really focused on direct-to-chip as where I thought the future was going to go because of the benefits I think it offers miners and heat reuse systems. So I'm glad to be part of this panel. We'll see how it goes.
All right, I just want to go, Antoine, I think everyone understands how air cooling works. Air blows over things and it cools them down. But I want you two to differentiate kind of between immersion and hydro because they kind of sound the same. They both use a fluid of some sort. So Dane, just explain like what exactly is happening with immersion, and then we'll have you go, Ryan.
Yeah, so immersion uses a dielectric fluid, so non-conductive, 95% biodegradable, has some random things in it. It's effectively mineral oil. Some of them are synthetic, but you got various manufacturers there, and what you end up doing is dunking the whole computer inside this immersion fluid, so you get a kind of constant, everything gets touched with this fluid, so everything gets transferred to heat through this fluid. And then once you usually end up, there's various systems out there, but the basic is through thermodynamic heat transfer. You get cold in the bottom, heat rises. You also have a pump helping that. Goes up, goes to an overflow, and then that hot liquid you can pass through a bunch of different heat exchangers and whatnot, and then back into the tank once you get it cooled. So just kind of the overview. Sure.
Perfect.
Yeah, so direct-to-chip it's actually pretty similar to the other two cooling methods. If you were to think about like an air-cooled hash board, you have your ASIC chips, those produce the heat. They make direct contact with a heat sink, and then the air flows through that heat sink, collecting that heat and removing it. Direct-to-chip cooling, instead of using a heat sink, it utilizes what's called a cold plate or a water block. That also makes direct contact with those chips. So heat is moved into that cold plate, but then you circulate water or water-based coolant internally inside that cold plate to absorb that heat as it circulates through. So it's very similar. All three cooling methods use a fluid. Air is technically a fluid that make contact with a piece of metal, whether it's a cold plate or a heat sink. And that piece of metal is connected to ASIC chips, and the heat transfers very similarly in all methods. So it's really the working fluid that is the difference between these three cooling solutions.
Okay, let's go next to where these are kind of being used. So Antoine, we'll start with you. Like, where is air being used? What are the extents to it's being used? I mean, on what scale is it being used? Kind of just an overview of like where is air being used in this whole setup.
Yeah, sure. You mentioned scale. I think that's the important thing here. I'm not going to say air is better for every application. Air is a low hurdle rate. It's less infrastructure. Building code dictates that most houses now have to be built with an HVAC system, a forced air HVAC system. So taking advantage of that allows you to cut a considerable amount of cost out of the system. Most homes are more than happy with 2 miners. My rule of thumb is about 1,000 square feet per miner. I guess just to go back a step, the systems I design are basically HVAC integrated. They can be used as space heaters, so standalone if you don't have an HVAC system, but I leverage the 8-inch AC Infinity Cloudline inline fan, as the large diameter does a couple things. It's way quieter, and with that 8-inch duct connector, you can basically use a duct flange and go straight into your air return plenum and then redistribute that heat throughout the house. So I guess the main points there are if you're doing small scale like residential, I see huge benefit to using an air-cooled method for ROI, sound, a whole bunch of reasons. Thanks.
Yeah, go ahead, Dane. Let's. Where's immersion being used?
Yeah, so immersion, I think, it can be used in a lot of different scenarios. One of the main ones that the original why I started working around that avenue was I got 2 miners and air cooled and sounded like a jet engine. The wife was like, "This is not happening, honey. Like, you're not running this in my house." So I'm like, "All right, we gotta figure something out," and kind of dove down. What was this now, 5 years ago, on what were these big manufacturers doing for Google and all these servers and stuff, and kind of found that's how originally kind of found immersion cooling. And kind of breaks your brain the first time. Putting a computer in a liquid is a really odd thing to do for the first time, but it's fascinating once you do transfer that heat to a liquid instead of just air. Like Antoine said, it's if you're just heating air in a space, it's hard to beat. Just like if you just want hot air somewhere, the barrier to entry is throw a miner in there and you got hot air. But once you put it to a liquid hydro immersion type of deal, you can end up pumping that liquid. You can transfer that heat anywhere. It doesn't have to be in the same area that you're heating where you're doing your mining. So you can put your miner immersion tank in a closet in a mechanical room and then transfer that heat through the whole house via radiant floor, outside to a jacuzzi, just to your hot water heater. You can transfer it a lot of different places. So kind of that's where the immersion, I feel like, and hydro kind of side, the liquid side really excels, is being able to take it on various heat exchangers. And a lot of different things we work on is boilers, alternative heating solutions. All these deals are already out there for heat exchangers, shell and tubes, blade spray, like they're all over. So you can, just with a little bit of research, the integration is just how you're getting the heat via computer now is now putting it in all these different scenarios is actually people have done for, I wouldn't say hundreds of years, but at least 50, so there's a lot out there.
Yeah. And then Ryan, as far as hydro being used, so I know the interesting thing is that we see home miners, like the smallest home miners imaginable are using air and actually immersion. There is an immersion bidax. So we're seeing immersion and air used all the way from the bottom of the mining industry all the way to like the big fat cats in Texas that need cooling in high temperatures. So like these two systems are being used, and I know hydro is being used in like large systems. So where is hydro or hybrid being used currently?
Yeah, so hydro is heavily focused on industrial scale right now. And it's really thanks to the physical properties of water. You can cool much better than using other fluids. So you can put a lot of density into a small form factor. So all these industrial miners are buying up these hydro miners because they can fit a ton of power into a small package. And that actually improves the economics of their mine. If you look at stack ranking, like the most profitable miners, the large majority right now are hydro miners. You get a big bang for your buck. So since you can put a ton of power into a small machine and they're very profitable, the industrial miners really like them. So the manufacturers have heavily been focused on providing hydro to the industrial size clients. That's why they're mostly 3-phase, so we don't have a ton of them that we can just hook into our homes and play with. We're now starting to see the first like 240 volt Watts miner that's hydro cooled, so that's pretty cool. But what we're trying to do actually is offer the same advantages of hydro cooling to smaller miners, to the tinkers, to the builders to go build, because there's actually a lot of advantages of water and of water cooling that if we can shrink and focus on the smaller clients, they can take advantage of those benefits. So to kind of summarize it, right now it's heavily focused on industrial, but I think that will trickle down over time, and we're kind of taking a bottom-up approach, getting in the hands of all the builders, everybody who's trying to reuse heat to take advantage of those higher densities, the better profitability, the more efficient miner. So hope to see it scale down to the tiny form factors too. We'll see.
So from a heating perspective, what do you guys think your system offers maybe as opposed to the others? Like, why should I choose air, immersion, or hydro from a heating perspective? And maybe which heating areas in specific are more well suited to your system? We start with you, Antoine.
Yeah, so I take an extremely pragmatic approach to this. Originally, I was doing what most of the other miners were doing, using a contactor or relay to kind of duty cycle the miner. So too hot, off, not hot enough, on. But in the last few months, 6 months maybe, I've come up with a system that uses LuxOS to kind of programmatically downclock or upclock the miner based on temperature. This all kind of revolves around the AC Infinity fan. So just kind of a background, the typically the way a miner works is it's targeting a hash rate, and then the control board will modulate the fan speeds and the wattage to maintain that hash rate. By breaking that relationship and prioritizing heat, what I've done is I use a fan controller on the AC Infinity fan, and that drives the fan speed. And then the fan speed is going to drive the wattage and chip temperature. So it's kind of like a backwards and inversion of how it's typically used. For example, so let's say you want the house to be 21 Celsius. Sorry, I'm Canadian, I'm in Celsius. The miner, the farther you are from 21, let's say you're 18 or 19, that's going to mean high fan speed, which drives a high wattage. But the nice thing about this approach is it will lower the fan as the ambient temperature increases. And what you get out of that is a kind of an asymptotic ambient temperature. So as the room heats up, or the house heats up, your temperature, your house temperature starts to approach your target. So you could be at 3,500 watts if it's 18 degrees in the house. And then as you approach 21, you're going to be downclocking, which has a couple benefits. Increased uptime, so you're not duty cycling as much, and way more efficient. You can take an old J Pro that's not profitable at current electricity prices, but you know, if you're down to 2,000 watts, 1,800 watts, which is the majority of your duty cycle, if you're looking at how an asymptote works, it actually, you knock yourself into profitability. So there's a huge advantage to doing that, and I think being able to take a $500 miner and ROI in 12 months and have break-even heating is hugely valuable. So.
Yeah. So do you think that, I mean, as far as like use cases, obviously forced air, I think, and space heat is probably the largest two targets for air-driven systems.
Yeah, I focus on residential because my philosophy is to kind of deliver the most amount of benefit to the most amount of people. It's probably more lucrative to target like not data centers, like Amazon warehouses or large, heating large volumes. But I really enjoy interacting with Bitcoiners, and it's been a dream come true to turn this into my full-time job. And yeah, I'm getting a lot out of it, and I see my clients getting a lot out of it. I see a lot of people who get one system because they want to dip a toe. Let's say they're not Bitcoiners, but they're curious. Many come back for, okay, I want to do the garage and the workshop. And so, yeah, that's been a nice experience.
Awesome. Yeah, all right, Dane. What is the best killer use case for immersion as far as heating goes? Or you know, it doesn't even have to be home heating. It could be Amazon warehouses. But where does it fit in best?
Yeah, I think immersion, my favorite one has been, not everyone has jacuzzis or tubs, but from just heating a domestic hot water is really kind of a fun one. And you end up with immersion, you have kind of almost a thermal sink with it too. So what you do have low oil, the whole miner is immersed in it, so you're sucking heat out of the whole thing, the power supply, the miner, the chips, even in between all the various, not even just ASIC chip part, but there's still other pieces that do heat, and it helps keep that heat across the miner consistent the whole way. And I think for immersion, getting it in a hot water heater is really a pretty simple integration, and like showering in Bitcoin, is kind of a fun one. Getting it in a jacuzzi or a pool, like people with pools, like just kind of the tease of when you're a kid wanting to swim in money, right? Like you can't get any closer to it than that, So when you're actually, living in the heat, like all these things, it's just kind of that mental switch. But getting immersion, it's just really fun just getting to see, having people asking like, oh, I really want to heat this or that or the other. There's a lot of integrations out there that have been, from just like basic hydronic systems on your wall to, radiant floor systems been probably the best, most effective, efficient use case for it, I think, for just heating spaces. But those aren't easy to retrofit,
Yep.
So there's definitely positives. And if you just need to heat a space, like we're saying, like air is great for that. But if you have some integrations already, or you're building a house around wanting to heat with Bitcoin. I have a couple clients who are like, hey, I love this. I want to heat my brand new house with this. And so, we're able to put radiant in. We're able to do, hook it up, make sure it's near his mechanical room and his hot water here. He's like, oh, I also got a jacuzzi right next to here, So like, if you're able to build it out, you can really tap into the major benefits of not only just heating, but the thermal sink that then that oil allows you to have and the consistent temperature across the miner the whole time, and being able to then use that oil in a bunch of different areas without losing a big delta on it.
Yeah. All right, Ryan.
Direct to chip and water heating or water cooling, the advantage is actually the flexibility. So you can heat water with it. You can put it over a heat exchanger and heat air with it too, like a radiator unit. But the flexibility, when you think about water cooling, it shrinks the form factor of your miner because of the ability for water to cool, but it also shrinks the form factor of the rest of your system. So you can have really small pumps, really efficient pumps, really small radiator units, and you can actually pump heat to different places very efficiently. You use really small diameter tubing. That's very convenient. So it's a very flexible system. So for example, we have a few use cases, some that we heat water with, but another use case that was interesting is we actually were able to capture heat in water. We vented it over just a skinny, small radiator that fit directly into a central HVAC unit fan filter. So where your filter goes, it actually slides right in there, so there's no updates that you need to any of the central HVAC. You can utilize the blower motor of that central air unit to pull heat off the miner. When we did that, the highest chip temperature on a regular S19J Pro that was running at 3 kilowatts was 58 degrees. So keeps it extremely cool, but it was taking that heat and it was moving it throughout the house at 75 degrees Fahrenheit. So you have heat dispersed through your home. You have a perfectly cool miner, and it's all thanks to the flexibility of water that you can make that happen. You wouldn't be able to take immersion fluid, sorry, Dane, and plug that easily into an HVAC unit because the form factor just can't shrink down enough to do that. So water's very flexible. You can say the same thing about heat exchangers with other liquids. You can have smaller heat exchangers, more efficient heat exchangers. You can also, your outlet temperatures on water can be higher. So we're seeing miners now outlet 80 degrees Celsius, which is insane. That can be used for a wider variety of applications. So I guess to sum it all up, there's no one good use case for water, and I think that's a good thing. It's because it's very flexible. So creating these plug-and-play systems where it can heat air efficiently and quietly, it can plug into a hydronic system, it can heat other hot water, other liquids. I think that's an advantage for water.
I want to do a quick go back though. I mean, that same, because
gloves come off.
Put the gloves
Shots
back.
fired.
We knew
Shots
this was
fired.
going to happen.
But 100%, Ryan, you hit the nail on the head with having a air to water heat exchanger, tube and fin, I think is another way you call it, heat exchanger. They're sized exactly for the plenums of these various air handlers you have. Usually if it's a 16 by 18 air filter, you can cut it and slide it right in there like you're saying, but I have that same thing in my house currently right now running with immersion. So it works. It's the exact same thing. What's kind of fun is you get kind of two different mediums you can play with immersion. Is like with water, you do have the water, cooling, and just like the build out you said, I'm pumping immersion oil through that same heat exchanger in my house, and it's kind of just treating it as the dry cooler for but it's still pumping the heat through the air, through the whole house. It's quiet still. It's just the normal sound that goes off your air handler anyways. So you can do it with immersion. I've done it in other editions where you already have the radiant floor system, or you already have dual loop is what they call it. If you go from like immersion oil to a glycol loop, let's say on a radiant or system or a radiant floor, or even just that sort of deal, is what your system already is just the water glycol loop, right? Like still having that heat exchanger and having those is integration that's been done and whatnot with immersion as well. And it can pump, because water does pump more readily than oil, it makes it so, yeah, you can pump it through things, but you do lose a delta between the oil and the water for that sort of deal. So you're kind of adding a little bit of a, what do you want to say? Just like you're losing a little bit of heat there because there's still heat in the oil, and so you got to size your heat exchangers appropriately. But that sort of air handler and that integration, I have mine running with oil, and it works great because it's like the hottest deal goes through there. And like with immersion, you're actually able to up the chip temps a little bit if you want and still have the system super stable, not any hardware errors, anything. So like you almost have more to play with when you have the whole thing immersed in an oil bath. You can end up getting outlet temperatures of your oil close, just for testing purposes. It's not on the something for super longevity, but I've had it running at my house for a 70-degree, 75-degree oil outlet with still a sub. It's kind of crazy talk. Schnitzel's still probably like, I go higher than
Schnitzel
that.
does. Schnitzel's a madman.
But, it's like there's kind of the happy medium you have for chips, but what's really fun with it is being that kind of thermal sink, you end up able to push the miner a little more and not have the chips get hot spots, just need the airflow through the actual body to still cool convectively. You end up able to push the miner a little bit more to get different temperature gradients if you want to.
So let's go into cost, because that's the next big thing, right? Like, air is obviously pretty cheap. I mean, air is that they already come with fans, so I mean, that's like free. Even an AC Infinity fan's not too bad, but like, what are these immersion systems and hydro systems going to cost? Up front. I mean, can the cost be recouped, and in what situations can it? Because we have guys like Patrick Patel out here who's got his device back here that's 4 watts miners in a it looks like an HVAC ready to go thing. That's one squirrel cage fan. I mean, the thing is it's affordable. So can hydro and immersion work in residential or commercial heating applications at a reasonable amount of cost? Like, can these prices be recouped? Ryan, we can start with you.
Yeah, I mean, I would say definitely. I think hydro, like I was talking about, it all comes down to scale and efficiency. That's actually the benefit of hydro. So you can keep your chips actually running very stable. You can route fluid to hotspots to target those exactly. But being able to shrink everything down, including the rest of your system, lowers your overall cost. So if you have a smaller pump, it's going to typically cost less. You have smaller, more condensed radiators, those cost less. You can look at some of the systems that are being built right now with hydro specifically. They're very small and condensed, and that lowers your overall cost. But at the same time, their performance is very high performing. So they're, like I talked about before, some of the most profitable miners. So they're able to scale the cost while increasing your performance. So you claw back that initial CapEx a lot faster with a hydro miner than other forms of cooling. I mean, it all depends on your application. Obviously, if you just want a little space heater, it probably doesn't need to be hydro. So there are different applications demand different systems, but that's one of the benefits of hydro is you drive down that cost as far as you can without affecting your performance. And in fact, you increase your performance because with better cooling, you remove entropy from the system. That keeps things running more efficiently. If you were to look right now at S21 XP, and I already dropped this on you yesterday, sorry, but S21 XP Hydro compared to the immersion unit specifically. The hydro unit, 52% smaller, so less than half the size of the immersion unit. It is lighter, so it's easier to ship, move, all that stuff. It's more efficient by an entire joule and a half per terahash, and it creates 58% higher hash rate than the immersion unit. So all of those together show the insane efficiency and density of that. So when I'm thinking about like what's the future of heat reuse going to be, having these really small, powerful, compact plug-and-play systems where you could just slide a hydro miner in, just an inlet and outlet that simply connects, very, very compact, that could heat your entire house. I mean, we're putting 11 kilowatts now into a single unit. That's plenty for a home for heating. So I think that's where it's going to go by driving down the cost of the entire system and the unit all in once without affecting performance.
Okay. Yeah. Go ahead, Dan, and then I'll jump in.
Yeah, no, I'll try and keep it relatively short, but I think something to just note on that though too, Ryan, is both those systems quoted, they're all 3-phase, right? Like thankfully now they're coming out with 2 split phase or 240-volt hydro miners. Your guys' system's great for that use. Watts Miner has a couple, but like some of those, hydro's been on this kind of interesting curve where it's kind of a we'll see type of deal because the longevity of air-cooled miners, we've all seen failures in air-cooled miners, like not, it's just the fact of how air transfers heat, right? But immersion miners, there isn't very many on the market for us, for plebs, for trying out. There's no previous real generation miners for hydro that we can check. We're like with immersion miners or what those, like I've taken mine apart now and they look like the boards look brand new compared to when I bought them 4 years ago, And so it's like, there's something to be said on kind of the longevity. It's been being tested now a long time, and in dirty environments, I think is really where you end up having a huge benefit for immersion, in shops or places where it's like there's dust, dirt, all these things, it's already all immersed, and from kind of a safety standpoint, you end up having immersion. If a power supply pops or something like that, it doesn't have the air factor, so there's no fire. You don't fire triangle, you don't have your heat and your air and fuel. So it's like you don't have that air to it, so you just get a little smoky bubble out of it if it's going to fail, and then you don't have a fire in your house or things like that. So I think there's something to be said for that avenue. But a lot of these things, immersion is probably the biggest cost as we're talking between air, Ryan's system with his hybrid, but like the hydro, I think the cost overall we'll just have to see as time comes on, because I'm curious on what the longevity of a home hydro miner is going to be, because they do have a maintenance factor where an immersion's almost, once you get it set, you forget about it.
My concern is yesterday, we were talking with Troy Cross, and he was mentioning, and I think this is true, is that it's really hard to be profitable. Like Ryan, I think a lot of stats you're saying I'm sure are true, but when you're running intermittently and seasonally even, we're talking really low uptimes. So it's really hard to be profitable on these miners when you're only running them. We may only be running these things 20% of the year or less, probably way less. So is there a used market? How can we even get, and I know what you guys are making is awesome. I think that's great, because that actually gives us access now to being able to combine an old miner, a used miner, which we can get for $300, and then, we can now retrofit to make them hydro. But is there even a used market right now that's usable in the actual hydro market? Like, we get micro BT hydro units. They are all 3-phase. Is that what's going on?
Well, they have a single phase now, but
it's new.
Yeah, correct.
Yeah.
So it's not advertised. You secretly have to get it.
Yeah, I know you do.
Oh, okay.
I want to get my hands on one. To answer that question, it's timing of the market. The price of a hydro is so high not because it's super complicated to make, and a lot of cases is actually simpler to make. You have more density, so you have less hash boards. You need less material cost to make them. The price of hydros are high because the market demands them to be high because they're so profitable. They're not going to sell you a very profitable machine for the same price of an air-cooled unit. They can charge a higher margin on that. And we're actually seeing that with manufacturers. There's a heavy focus on hydro because they get a good, healthy margin on it, and because miners are also profitable with it. What we'll see in the secondary market is it takes time. It's just like we don't have S21s that are affordable because they haven't been around long enough. So we'll see that depreciation, and as they get less profitable for mega miners, the same thing will happen with hydro miners. No one's going to want a hydro miner that's unprofitable on a large scale, so it'll become an S19, and then we'll have already assembled direct-to-chip, liquid-cooled, power-dense, very efficient miners. So it's right now, I'd say no. You can't go buy a hydro miner that works on single phase, but it's all market timing, and we need to plan ahead of these things. We can't just build a whole market for what we only have now. We have to think about, okay, what's the actual use case going to look like? And again, if you get back to just simple plug and play, imagine plugging your furnace in. Imagine somebody coming over to maintain your furnace just by unplugging it, shipping it out to get fixed, and then plugging a new one in. And I think that's only possible if we're using something like hydro because of that ability to absorb that heat.
Why would that not be? Well, okay. Antoine, why don't you build us a case for why air should stick around? The use cases that you think air will continue, if there is a future for air. Like, will air be around for heating applications in 5 years? Once these hydro miners are on the market.
Yeah, I think so. Just because, like I said earlier, the infrastructure is already there, so you can leverage that. Cost is extremely low, so it's nice to deal with Bitcoiners, but it's also nice to make Bitcoiners out of clients who are just interested and curious and have that nature. So that's a huge plus, I think, getting people on board. I just wanted to quickly address something Dane said about the dangers of air. There are systems you can use to mitigate some of these dangers. Like I have a product called the Wi-Fi PDU switch, where it integrates all these Wi-Fi temperature sensors, and one just magnets straight to the PSU side of the board. So if anything starts to heat up, it'll take the relay offline and it'll cut power to the miner. It's also kind of like a redundancy for if you're overheating a place. So it'll cut power if the downclocking isn't enough to, let's say it's summertime, it's already 23 degrees Celsius outside. Your miner will just shut off in that case. Back to its viability for the future. I think that it's the lowest entry point. So I do think that the economies of scale are better with liquid cooled systems. But that said, if you're in a residential setting and you only need 1 or 2 miners and you don't have any experience or history, it's a really low hurdle rate to get up and running. I don't even install them. I basically build everything in-house, disassemble it, put it in boxes, and then a 6-hour phone call is enough to instruct someone on how to put these together. And that's one of the things I think is going to be nice in the future. The education component is something it was undervalued. And when I started educating people on how to do this, what pool to use, how to connect a pool, I barely spend any time dealing with, dealing with issues and tech support, because when you go through the steps on how to build one of these systems with the client, after that, they're equipped with how to, it's not hashing, restart. You got to put the pool in. They know how to resolve. They're extremely simple. These are appliance grade heaters. Bitcoin miners have no buttons. They're extremely simple and reliable. So as long as the user has proper instruction, they can operate them without any external help. And I think that's hugely valuable. That education is one of the highest value things that I can offer, I think.
Antoine, you just always been an air guy? You weren't tempted by the sexy allure of these liquid
Oh
cooled
yeah,
miners?
when I saw those fog hashing units, I was like, the branding in the yellow and black.
Yes, I mean, I couldn't turn away.
Yeah.
Did you? You weren't like, but did you ever delve down the immersion route and did you bail, or did you just be like, no, I'm an Air Maxi forever?
No, I'm not Air Maxi. I'm a pragmatist. I think there's a good solution for every problem. If you need 6 miners, then you can take huge advantage of economies of scale with immersion or liquid or water. But I chose that route because of my mandate is to deliver the most amount of benefit to the most amount of people. And it requires that I have a lot of small jobs that I do, and that can be annoying. But at the end of the day, I prefer to do that than set up an Amazon warehouse with heating or I love learning, so I would love to eventually get my hands wet and
Greasy.
But I'll stick with dirty over wet for now.
Dane, take your best shot at this hydro. Take your best shot at the hydro, guys. Why should immersion be around?
Gloves off,
will
Dane,
immersion
gloves
even
off.
be around? It's greasy. It leaks sometimes, and you have these oily spots on the floor.
Yeah.
Like, why should people be using hydro or why should people be using immersion and not just go to hydro? Is it the better liquid?
Yeah, I think there's a lot there, and I'm kind of going with what he said. I think there's a lot of different applications depending on what your use case is and where you're at and what you're building, what you're trying to heat, what you're building, where you're at right now. And I think kind of just a little bit of a go back too is, immersion. What I do enjoy about that is, I shouldn't necessarily say future proofing, but if you build the immersion system, it's kind of new generation miners, older. You can put a lot in it. Where if you get let's just say not necessarily Ryan's system per se, but the brand new WhatsMiner Hydro, it's the only kind of, I think there's 2 single phase hydro miners. Don't quote me on it, but let's just, for argument's sake, let's say there's this one new one that you can't really get your hand on right now. You build a system around this, and from kind of a application standpoint for building out a whole product, if you want to have it replaceable, well, you're kind of stuck now to that exact form factor that you're replacing. So when now Bitmain comes out with their weird square tube that's a little bit longer or whatever, you end up, it doesn't quite fit or doesn't look the same. Where with an immersion system, you can put S19s in there, 21s, newer ones. The form factor changes a little bit, but that's just part of the manufacturing and designing a system that I have to work through. I mean, there's lots of people, you can build your own immersion system, and I'm all for people DIY, and I learned the DIY and messed up enough that I was like, hey, there's some value to if someone doesn't want to DIY this thing, like, you build it out to a certain volume and ability to be able to change and kind of build your system, but then not have to change out everything in your system every 4 years on a halving cycle or something. So I think there's something to be said about, scale for sure, but also just adaptability over.
Yeah, fully modular. I like that about the immersion.
Can I throw one in there?
Just tell us, Ryan, why? Because I'm like the shiny new thing guy. I'm like, I went from air. Now I have data system heating my house. Next thing you know, I'm going to scrap that and have hydro. Are we going to have anything but hydro in 10 years? Is it all going to be hydro? And why don't we have it now? I mean, the hydro's not some cutting edge SpaceX technology. This has existed.
You want to hear my theory on it?
Let's hear it.
All right. So we'll have all three cooling systems. Again, we're debating our own up here, but there's totally areas where immersion is more beneficial and where air is more beneficial. So it's not going to be a one-size-fits-all. There's never going to be a single cooling system that everybody uses. Look at data centers. They have many different cooling systems. I see us going down a similar route as that. My theory on why we don't have hydro yet is because if you think about how ASICs were manufactured, and I ran through these problems, so this is why I think this, but I wanted to do direct-to-chip back in 2017. But when I had an S9, all the heat sinks are thermally pasted onto the chips. I sat there and I would remove them all with the thermal gun, and I would take out tempered glass, perfectly flat with sandpaper, and try to lap the chips, it's called, to make a flat surface to then attach a water block to that, and that never worked. That was not scalable, not practical. Why would anybody do that? Same thing with the S17s. Those were all soldered on. I tried to do that as well. Remove all the heat sinks, try to wick all the solder off to make them flat. Not practical. The only solution at that time was immersion, which had a lot of benefits. You could, remove the noise. You could capture the heat in liquid. So everybody started to move towards immersion, and it had a ton of benefits to industrial scale miner specifically. But then the S19 came out. We have simply unscrewable heat sinks that pop right off, leave you with a perfectly flat surface on all your chips. And that's why now we see the introduction into hydro. So air obviously had a big advantage starting first. It was the most simplistic. Immersion caught on as the later generation, a better way to cool. And now we're at really what I would say even the beginning stages of hydro. We're starting to see these systems transform. So we'll still have all three, but that's why I think we haven't seen, hydro's not new. We've used it in data centers for decades. Your water has run on hydro cooling to cool your engine for decades. So water cooling's not new, but it's newer to ASIC mining because of how machines have progressed.
So do you think why would Riot choose immersion over? I mean, this is not we're branching out a little here, but I'm just curious. Why would Riot have installed these gigantic immersion systems because I believe hydro was available at the time, I think, or maybe it wasn't.
I mean, I don't know whether it was or not.
Okay, maybe
but
it wasn't.
There are advantages to running large scale immersion.
Okay.
So when you're managing tens of thousands of machines in Texas or whatever, and if there is humidity, it really depends on your exact circumstance of whether you're going to want to use immersion or hydro. Mm-hmm. So I'm sure they went through their due diligence. They factored it all in. They built their own systems too, so they were able to cut costs doing that. They're in Texas, so they can probably acquire immersion oil pretty cheaply from all the manufacturers. Think logistically on shipping oil from somewhere in Texas or to somewhere in Canada. It's going to be a little bit more costly. So all those factors kind of boil down. So I don't know why they chose immersion specifically, but we do see a lot of people now choosing hydro. Mm-hmm. If you look at the heat reuse projects in Finland and Denmark, those use hydro machines. They're able to outlet a higher temperature. They have very dense systems that create a lot of heat that can heat entire cities. So I think we'll see both systems still. I don't know why Riot specifically, but each have their advantage.
Yep. All right, so I'll just ask, we're going to start wrapping up here. I want to ask each of you guys just the one last little thing. We'll get into maintenance, what kind of maintenance is required, and from a maintenance standpoint and reliability standpoint, how does your system compare maybe to the others?
Yeah, so for me, maintenance is really just changing the filter every 3 months. I filter all the intake air. That's just kind of like a risk mitigation factor for making sure no bugs fry themselves on the hashboard or anything like that. Everything runs cleanly. So that takes about 5 minutes, and it's you can get a roll of replacement medium for $20. So that's pretty much the only maintenance you need to do. I've run these machines through filters for years, and I've tried to clean them, and there's really nothing. There's not much to clean. So that's pretty much the only maintenance required.
I mean, that's the same as like your furnace, I guess, right? I mean, really, there's no difference there for the user. It's just a
Exactly.
matter of like you're supposed to change your furnace filters, so change your furnace filters.
Yep.
Yeah.
That's pretty much it.
Okay. Dane, maintenance.
Sorry. From a maintenance standpoint, I think that's kind of where you end up. Immersion takes a cake on there. I think why larger scale miners, but also for just like set it and forget it type of home mining stuff, because there really isn't maintenance you need to do. I think the biggest work you do for an immersion system is the setup and the prepping of the miner. If it wasn't brand new or you didn't buy an immersion specific miner, is taking the fans off, cleaning it out, getting the dirt off of it from it being an air system, and putting it in there. I mean, I've had people just slam them in there dirty. And
We just did it.
I mean, that's what that one is. But
Those were dirty.
those were dirty.
There's a filter though, no? Did you guys have a filter on that
in
one?
there,
That was
no,
on the
because-
water side.
Oh, okay.
Yeah, and on the immersion side, what's kind of interesting too is like, if I've seen some systems where they don't put a lid on. I mean, it's simply a lid, just like keeping the bugs and the dirt and the dust off the oil is like, okay, so there would definitely be a maintenance thing if you didn't put a lid on it. And so, I mean, I've been to some immersion sites where it's like the oil is the nastiest, reddest, weird color from blending moths through the pump, like.
I don't think this is something to be too dwelled upon, but I will say when I'm working with immersion, I feel safer than when working with hydro. When I'm down in my basement, when no safety precautions being taken, immersion, I'm not concerned about electrocuting myself. But when I was putting together my cryo block, I was like, oh shit, there's water everywhere. I am covered in water now.
There's
This is probably my
definitely
own problem, but.
I think there's some truth to that for sure, but I mean, there's simple
Sure,
precautions that
sure.
you just
No,
would
I don't think
take
that's. I
as
don't think
an
it's a
industry.
real credible
Yeah.
reason to avoid hydro. But
Exactly,
Ryan, what's
but-
maintenance like on, or maintenance or longevity like on a hydro
On hydro,
system?
yeah, definitely. Obviously, safety precautions are needed, so I'd advise that. But with hydro, you're utilizing water. Water freezes, unlike oil, so you have to take added precaution on your environment and how you plan on using it. So you have additives that we've used again for decades, added into the water to lower the freezing point. Ethylene glycol, your water won't freeze then. Corrosion inhibitors as well, so you can run these things for really. There are now lifetime corrosion inhibitors. I've never tested them. I don't know how they go, but there are reports of lasting 5 years with very little to no maintenance in a closed loop system. It's recommended that you probably replace the fluid every 6 to 12 months. Just quickly drain it, fill it back up, and then you're good to go for another year. It's very low maintenance as well. I mean, just like draining water out of a spout. It's pretty simple. So maintenance is, there's obviously immersion is very maintenance free, which is great. There's a slight addition that you have to, and precautions you have to take with water. But again, then it's like cost benefit. So.
Can I do a quick kind of just jab a little bit at
Definitely.
hydro? here?
Definitely. Yeah.
But there is something too, like when you're quoting this high specific heat of water it's definitely like paramount to anything else we have in the world. And that's, immersion doesn't have that same kind of absorption ability of heat. But once you do start working with water in freezing temperatures and you add propylene glycol, that actually drastically reduces that specific heat. Like if you can just run water,
Still better than immersion oil, though.
still better. Okay, but it's actually getting more on the evener keel now, because if a 50% mix, if you have somewhere that's freezing, I'm just talking on a radiant floor system.
That's an interesting point, actually. So I have a radiant floor system. So I think about this because I have, the propylene glycol on one side, and it's rated quite low. I mean, I have a lot of that stuff in there to keep from freezing. But I think of it now, okay, the immersion side is the limited side usually, right? The oil transfer, the heat transfer from the oil side is going to be the limiting factor in my heat exchanger. But I guess if you're going with a hydro system, you'd have the opposite problem where the water is now able to release more heat than the glycol is able to absorb. But if you're putting coolant, what I'm saying is that in the end, if you're doing a water-to-water loop, like a liquid-to-liquid loop, like I'm doing, you'd be perfectly balanced with hydro because you would cut the water with propylene glycol, and you would cut the floor system with propylene. You're basically running the same thing on both sides.
Yep.
So really, it is balanced, I guess, in that respect.
It's balanced in that, and it does. I mean, your specific heats and all your physical properties of water change depending on what additives you add to it. But there's more than just specific heat. Again, specific heat, even with additives, is still higher than immersion. But you also look at thermal conductivity. Thermal conductivity of water, even when you add glycol or propylene glycol to the mix, is still 3 times higher than immersion fluid. So that's how quickly heat can move into water through
State
water.
your source.
Yes. We're going to need a fact check on that.
So heat can move into water, through water, out of water much faster. You also look at things like the viscosity of it. So water's easier to pump, but in a heating or cooling system, it creates turbulence in that system easier than a more viscous fluid like immersion fluid, which is really important for heat transfer. It still maintains that property even when you add additives to it. Then you consider density as well. How many atoms are literally interacting with heat to remove heat? Water with additives is going to be denser than immersion fluid. So it's not just one specific thing. When you add additives, it does drop it compared to pure water, but you still maintain a very high margin over other fluids.
Well, I'm not trying to pick on you, Ryan. I'm only picking on you because I think you do have such a compelling, case with the hydro.
Thank you.
But I think next year maybe we'll just have to have some kind of design, like you two will have to come together and decide who gets to heat the hot tubs, or even better, we'll have 3 independent ones, each heated by different systems. Air
And one empty one.
Yeah, there will be
one empty.
One will be a dry. It'll just be a sauna. There'll just be an air. Actually, there'll be a
Jacuzzi. It's a jacuzzi.
We could use a drying station actually, because there's no towels out there.
It could be an aerator with a jacuzzi.
That's true. That's true.
Could be
We
an
should do
aerator.
that. So next year, look forward to that. Well, guys, we're out of time on this talk, so we're gonna take a break. Go take a 5 or 10-minute break, and then we'll be back in here. So yeah.
Thank you.